Hello, everyone. Thanks for joining us today from different time zones. We are so excited to see you here. If you haven't met before, my name is Goli. I'm the VP of Customer Success at FlexRule, and I have Arash with me here. Arash is the FlexRule founder. In our today's webinar, we are talking about the most exciting topics, when and how to combine machine learning and business rules in decision management. We will show you the entire process from modeling, testing, and combining machine learning and business rules and the execution in a live environment. Before we start, a few housekeeping items. First of all, we are recording this session. If for any reason you need to jump off, don't worry about it. We will send you an email and we will provide the recorded session later on. We love to hear from you. If there is anything you'd like to share with us, there is a chat box in the Zoom, and you can put there, and I will be I'm online here with you. We can have a quick chat. Also, it's the Q&A box on the bottom of the Zoom. If you have any questions, we will have a 5-minute Q&A session at the end of the session. Please put your question there, and yeah, we will answer all of your questions. Great. Let's start with who we are. FlexRule founded in 2008. We are based in Melbourne, Australia, headquarters. Our mission is to empower all leaders, business, operation, and technology to empower the speed and quality of key business decisions in changing environments. We have customers around the world, North America, Europe, and of course, APAC. And very interestingly, across a wide range of industries such as finance, insurance, banking, government, and etc. Fantastic. To start our exciting webinar, I'm handing over to Arash. Arash, all yours.
So thank you very much, everyone. This is a webinar about combining machine learning and business rules, predictive and prescriptive analytics. But I would like to talk about something far more interesting, microwaves. The piece of equipment that sits in the kitchen, and we almost use it every day, and everyone has used it almost around the world. Yet, we don't know how to create one from scratch, most of us at least, and still trust the device. So do we trust the device by opening it up and look at the wiring, make sure it goes through the instruction that engineering team has put together? And when we want to cook something in a kitchen, we rather do the innovation with our ingredients, mix them, taste them, and make sure that the end result is good. But do we want to start building the microwave in that process from scratch and then get to the cooking? And if we are running a party and we need to hire people to do the cooking for us, do we go to any microwave manufacturer and ask the engineering team because they know how to build the microwave from scratch to manage our kitchen and put them in the charge of the food? Unfortunately, in the field of data science and computer science, that's how the things are being done. So universities, online courses, and every content you can find, they're mostly focusing on building machine learning and business rule engine from scratch. And there is little on applied science of the things like how do we identify a business problem and solve them with these relevant tools. And there is no surprise there that you can see 53% of the projects only go to the production from prototype. And when organizations put together a team from data science and computer science and PhD algorithms, and they hope they can identify the business problem and solve them, well, hope is not a strategy. So what is machine learning? I like to think the way that Kathy talks about it. Machine learning is a thing labeler. So it learns from a set of data, and then you put that in a situation, you point it to a specific data point, and it decides a result. This particular small video you see is about the Silicon Valley. So a machine learning identifies whether this particular food is hot dog or is not a hot dog. And this is easy way of explaining the labeling. So a label might be categorization. So hot dog or not hot dog might be price tagging, for example, the price of a house or property or whatever it is. And in different scenarios, you can see we use machine learning to take a decision. However, that decision that we make with a machine learning or business rules are very different from the business decision that business leaders are thinking about improving using technologies. And we can see across the board in any business, leaders are acquiring and purchasing technologies such as machine learning and AI and business rules and relevant technology with the hope that they can improve the business operation by improving the quality of the business decisions and the outcome they're looking for. So there is a very big gap between what a decision is in the context of the machine learning and business rules to the context of the business. And if we don't recognize this gap, we're going to solve a problem that doesn't exist. It's not important for business. And it's not surprised that you can see this approach ends up 85% of the project become irrelevant to the business. They don't deliver any business value whatsoever. So let's go ahead and understand what is a business decision and how is it different from the decision in the context of business rules and machine learning and the technology that we're talking about. Business decision is a business question that requires an answer. Here is a couple of examples. For example, where to put your specific products, where to sell it, how much do we sell it, what's the price point and discount strategy for a specific segment of the market and individuals. How do we prioritize the product offering for a specific customer? What is the best next action or task for an individual or an agent? So you can see across the board in any business, we have so many of these business questions. These are called business decisions. And why organizations really interested in business decisions in that context? So Bain and Company did a survey. It's a very comprehensive study. And the result of that study is amazing. So it says business decisions have a direct correlation to financial results of organizations and shareholder value. And they conclude that ultimately, a company's value is just the sum of decisions it makes and executes. So you can see the importance of business decisions from organization point of view and the gap between the definition and what leadership thinks about business decision and the business decision and the decision in technology, business rules and machine learning. So that's a big gap. Now, in the context of business decisions, there are different types of business decisions, strategic, tactical, operational, and not like the traditional view, they really don't have a clear-cut boundary. So let's take an example. Let's say an organization wants to go to a specific segment of the market to penetrate that market using pricing and discount strategy. So is it a strategic decision, or is it tactical, or is it operational? So we want to win a market in a specific segment with pricing and discount. So that's a decision. Now, policies and procedures should really enable the organization to do that. And in the operational level, they have to engage with clients and give them the price and do the discount. So it really is a combination on all of them, which you can see at the area number 4. And when the situation is like that, you have to use multiple different technologies to solve this particular problem, to implement a business decision to really impact the organization's in a positive way. So how do we do that? A complex business decision should be decomposed to smaller, easier to understand decisions unit. And we're going to go to more details on this topic in this webinar. And this is called framing business decisions. And once we've done that, it actually solves also a big problem. The positive side effect of this approach is now we are relevant to the problem that matters for business. We're solving the problem that is the expectation of the business from the technology and technology leaders. Let's have a look at an example in health insurance. So if I am an office worker going to get a health insurance for myself, it is very different from a nurse to taking a health insurance for that particular individual, because they are exposed to more risk than me sitting at the desk, right? So if we represent the calculation of the health premium as these green rectangles on the screen, and this is a complex decision you're going to see in a minute. Let's see how we decompose this. First thing first, we need some information to taking this decision. And we can define the fields of information later on in details, but at the very high level, you can see this decision requires the information input about the customer data, additional data about the customer, such as residency status, incoming coverage type, etc., and some other information related to situational decision, like, for example, COVID vaccination or workplace or residency status, so on and so forth. So you can see this diagram very clearly shows the data information requirement for this particular calculation of the health premium for individual. We go to the next step. So how do we do that? We need to calculate the base premium for an individual. And the base premium calculation has two different decisions itself. So we need to calculate the baseline price based on all the historical data we have for this segment of the market and this specific customer segmentation. So we can use machine learning and AI algorithm to build that algorithm and feed the result back to the decision. And then we need to calculate the extra charges, which is based on residency status, coverage type that they're asking for, and the income of that individual. And if we go ahead and we look at the calculation of the health premium, we have some situational decisions regarding whether or not this particular customer is eligible for discount and how the COVID situation is for this particular individual. So you can see at this screen, we just decomposed a complex decision on the calculating a health for an individual to multiple different smaller unit of decision making. And the good thing about this approach is now we can use different technologies. We can combine, for example, the baseline price calculation using our AI ML capability. We can use the other decisions using business rules, and even the business rules can be modeled in different ways. So this is called a decision graph, and it brings everything together in terms of how we want to calculate a health premium in a unified way, so you can have more transparency and gain the trust, because you really can communicate with your business stakeholders about how we made that decision. You can make sure it is relevant to the problem they want to solve, and it is aligned with the business objectives, because you don't just shoot in the dark and pick something that you think is important. You have a blueprint of a decision that is important for this particular scenario, and you can use your technology to solve that. And it gives you the flexibility of choosing what technology you want to use. A business decision might be rule-driven. So rule-based decisioning, you can use different types of rule modeling. A business decision might be data-driven, so you can use statistical analysis and machine learning and build an algorithm that does that calculation, which we are going to do it in this live session. A decision might be inconclusive, so based on all the investigation, running the algorithm, you cannot find a reasonable pricing in this situation, so the decision is inconclusive. Therefore, you can hand over that to a human in the loop, domain expert intervention, and a case officer can investigate it further. And the decision might require to understand, for example, different parts of the decision-making, like data extraction, from interacting with hard evidence, pay slips, or, for example, interacting with legacy systems which they don't expose API. So you can use decision robotics to do that. So you can see all of a sudden you will be orchestrating around everything around a business decision to make that happen. So at this point, I just jump to the live environment we have, and I want us to build this specific decision together. I'm hoping that you see my screen.
Yeah.
Now, let's create a brand new project here. This is our authoring platform, so you can see it on the screen. And we're going to create a brand new project. You can open it from your model repository, which is compatible with Git, or you can open the existing project, which we're going to do that in a minute. And let's build a new project from scratch. So in this environment, what you can see is we're created a new, brand new project. So let's go ahead and create a decision graph. We call it premium calculation here. And if you open the decision graph, you can see a blank canvas. There is a toolbox at your right-hand side. You can drag and drop and build your decision. So that is the premium calculation. I just write it in short because that's easier. And then you can drag and drop and you build your decision. So you can see I just drag and drop and build my decision, situational decision. And let's add another one, which is the machine learning decision. We want to build it here. Baseline pricing. Now you can link this one to a regression algorithm that we want to use. This is price, for example, pre-Victor. And at this point, you can see it talks about building the machine algorithm here with this user interface. So we're gonna source the data input, a sample data, and we're gonna look at the sample data first. So you can have a preview of data. This is the data you can see, but preview most of the time it doesn't solve your problem. You can look at the data more deeper. So if I load this data here, what is going to happen is that you can see at my toolbox now there are some data analysis available for this particular data we loaded. If you look at the, for example, fields of data, you can see we have different field of information loaded from this particular data source. Let's have the unique values of all of these fields that we have. Right? I uncheck this one because this is the index for a particular data record. So you can see here we have variety of the charges based on the information we have. We have 4 regions for this particular data set. Only 2 smoker values, so we can probably guess this is can be a Boolean value, whether the person is smoker or not. We have 6 unique values for children, and so on and so forth. So you can see there are 2 6s and 47 different unique values. Now, based on this information, we can say the smoker, if you look at it, is a string value. So let's change that to a Boolean value so we can further analyze the correlation of the features here. So we can select the data source and we can open the underlying data, how we load it. And if you look at this, this is linked, the orchestration layer allows you to build a whole complex orchestration around this data loading. And you can build your pipeline transformation, changing the values, fixing the null values, and all of that. But this is pretty much done for you. So if you look at the smoker here, the smoker value is a string value at this point. So let's put a function here to change that, convert that to a Boolean value right when we load them. Now you can see if I run this again, the smoker value now is a Boolean, so you can see it as a checkbox here. So let's further analyze this data. We want to create an algorithm based on this data, a machine learning algorithm that predict the charges of a particular situation for an individual. But before doing that, we need to understand the correlation of the features we want to use in this algorithm. Object index is the index for a particular row in the data, and charges is the one that we want to calculate. So we exclude that. We want to technically look at the numeric values, including a Boolean value. You can see now the smoke is a Boolean because of that conversion, and see the correlation between them to make sure we are using the right data for the right problem. Now, you can see in this heat map, if we have a very red or purple, that shows the higher positive or negative correlation. And here you can see, for example, smoker and children, they're a bit correlated, but every result for this correlation is less than 0.5, so we are good at this point. So we can confidently select the feature we want for this prediction. So let's go to the next step. We want to calculate the charges, and we look at the data correlation. We are confident that these are the features we want to select. And we're going to go ahead and we want to create that machine learning algorithm. We want to train the model. Now, here you can see at my screen, there are different algorithms that you can select and you can configure, but we're going to go and let FlexRule does that for us. So I'm going to start that process. And what you're going to see is all of a sudden, at this part of the screen, it says we are building that machine learning. Now, 80% of the process is done. Now the machine learning is built for us. So if we drill down to this node that was the machine learning part, you can see there is another decision graph which includes that machine learning that we just built. You can see we also generated the permutation feature importance. So the smaller it is more relevant to that particular feature in taking the decision and calculation. I just closed this project that I built, and I opened the one that we have fully implemented. So you can see we just created the machine algorithm here, and then there are other decisions in this particular calculation, the decision about how much an individual should pay for the health insurance. It's not only the machine learning now. So let's drill down to this COVID-related decision. So you can see this is pretty much a rule-driven decision. Sometimes when you're now combining the different technologies, machine learning and business rules, the benefit is for certain situations, you might not even have a data or relevant data to build a machine learning. So you need to augment it with other prescriptive decisions like business rules, which in this case, we're using decision table for model business rules. There are multiple different ways: decision table, natural language tree, subtree, etc. So let's have a look at this particular row in this decision table. This is a rule in decision table related to COVID. And the other benefit is when you do that decomposition of a complex decision, now you can focus on a specific decision rather than having a big bucket of rules problem, a repository full of rules that you don't know the relation between the decision that you want to make. Now, this framing a business decision allows you to focus on a specific decision here. And if you look at the decision, that is the COVID-related decision because we're drilled down to the COVID from the decision graph. Now, in this particular row, row number 3, if you select a row in decision table, it is your rule. And this one says, if the age of person is between 50 to 65, inclusive, because of the square bracket you can see, and the customer is working in the hospital, aged care, COVID quarantine center, etc., then add $200 on top of the extra charges for COVID-related charges. There are other ways to model business rules. I opened this one. This is called natural language. And we call it natural language simply because you can read from it. It says when coverage type is hospital only, coverage type charges is 100. So we add another 100 on top of the extra charges based on the situation. Now, this is a decision that we have now implemented with our machine learning algorithm and multiple different ways to model the decision using business rules. Once we've done that, in FlexRule, you can actually put the authoring environment, the FlexRule designer, into the simulation debug mode, and you can go one by one into every single decision you have. And you can see the yellow arrow, yellow highlighting here. You can see all the values related to different information we wanted. So this is a 35-year female with 20 BMI, 1 children, etc. And the extra charges of this particular individual is that it was COVID positive, and the rest of the information you can see on the screen, right? Now we can go to individual decision based on how we want to go to details of execution. We don't want to see, for example, the discount, how the discount works. In the income, we can drill down to the income. You can go step by step to different rules and see the execution. I'll just stop the execution here. And you can see based on the machine learning execution and the different decision related to this particular individual, we calculated this pricing. So the base price and the extra charges and so on and so forth. Now, the other benefit of using a decision graph and decomposing a decision to different sub-decisions and easier understand is that it gives you the full transparency and explainability. So if you look at now, the way we calculated this particular amount for this individual is based on a set of business rules, and you can see exactly which one of them been executed and which one were not relevant. So for example, if you look at this, it says we added $400 because these conditions were matching that criteria. So was the COVID positive, haven't received the first vaccination, and the result from our baseline calculation and also is clear. And we had this amount of discount. So it gives you really the full transparency on why a decision's been made and how this decision's been made in different parts of this whole calculation. Now, in order to deploy this, there are multiple different options in terms of deployment, and you can simply deploy it as a service and consume it from your application by calling to the service, or you can, what you can do is also you can integrate it in process into your application using the SDK that we provide, but integration and deployment is part of some other webinars. We can talk more in details. So that's pretty much about what we wanted to discuss and what we wanted to show. If there is any question, we can take questions.
So, right, let me have a look at the Q&A, Arash. Give me a second. Okay, one of the questions is that you mentioned briefly about the deployment, but one of the questions is that how do you deploy the model that you built and where we can deploy?
So let's say you build this model and you want to do the deployment, right? So you can simply call, open the package builder from FlexRule, and it's going to package everything for you. The related decisions and documents and everything that you defined in FlexRule will be identified automatically. You can see on my screen. And then you can say, where do you want to deploy this particular decision? You have multiple options. You can go serverless. We built-in support Azure function, AWS Lambda, and Google function. Or you can deploy the infrastructure for executing the decision as a service using a product called FlexRule Server. Once you configured your infrastructure using the FlexRule Server, then the deployment is one click away, either serverless or using servers in terms of the deployment. And if we, for example, select the Azure function, the only thing you need to do is put your subscription here and press publish, and the decision you have created and tested and you're sure it's working will be available as a service for consumption.
Right, sure. Arash, one of the questions is that if we like to reconcile model results from different existing models, can FlexRule manage multiple models and put the results together to form as a one final recommendation?
Absolutely. So it's actually a very good point. So let's say in this particular example, we want to do that. So let's build an orchestration layer here that combines multiple decisions. So at this example, we have the orchestration, there is a start, there is an end, and let's drag and drop that decision here. So if I open this decision, what you're going to see is exactly the decision model, the decision graph we created here. So let's say after this calculation, you want to call to a Python or R program that you have and you hosted as a service, and then you can grab the result here. So this is a REST API call. And then let's say you want to now create the combined result from those two executions. So if you look at this, now what we've done here, let me do this, is we go and we call to our existing decision model, decision graph that we created here. We're going to go and call a Python model and grab the result here. And then we have a full capability here to manipulate the data, create the result JSON, for example, having these two decisions combined together and send that to the end user. And we have the different ways of doing that. So you can create, for example, what is called is IRD, Information Requirement Diagram. So in the IRD, you can go ahead and create a model that combines the result using, for example, different data operations. So you have a result from the first model, you have a result from the second model, you pass it to Information Requirement Diagram to create the consolidated result, and then you pass that to the end consumer.
Right. There is one more question, which is exciting. Some of our customers send the printed proof of purchases. How do we read the data from those paper-based documents, and we can make decisions using those information?
So as part of the FlexRule capability, we provide the very sophisticated, advanced, and accurate OCR integration. So if you use FlexRule, you have access to OCR capability, and you can use the OCR to read the information of the paper-based evidence and take the decision based on the result you read. And our OCR is very accurate, generally is around 99.5%, even on the low quality images.
Right. And one more last question, because we have just 1 minute, Arash. The question is, what are the options to create and model business rules?
So we touched on the business rules a little bit here. It was mostly focused on the decision graph and the combination of them. But there are multiple options in FlexRule. One is a decision, one is a decision table, which I showed you. For example, if I open the COVID decision, you can see a decision table. In decision table, the green column are condition, pink column is the action. You can have as many as condition or action. The other option is natural language. Not this one. In this model, the other option is natural language. So you can define your business glossaries and business terms and use them to define business rules. And the other option is 3 sub 3, which we didn't use in this scenario. So 3 options: decision table, natural language, 3 sub 3 to model business rules.
All right, great. Arash, we have one more question, and then we can finalize this webinar. The question is that is in FlexRule, are the algorithms we have for the machine learning model training at par with the machine learning community? So
there are multiple options in how you build the machine learning algorithm and how you can use. Okay, so one question is, what algorithms do we provide? So at this stage, we provide multiple different algorithms in regression, classification, either binary classification, multi-classification, and around 20 different algorithms for each individual machine learning task. The other option is you can build your algorithm and bring it to FlexRule. So we have PMML integration available. So if you export your algorithm from wherever the platform you build, you can import them here. And rather than using here, you can see we'll link to a model that is called FRML. So you can use, rather than FRML, you can use your PMML. So you can simply bring your algorithm as a PMML to FlexRule as part of the decision graph, or you can use REST API call here directly in your decision graph to do your execution. So you can come here and you can say, on this particular, for example, decision I want to call to a REST API. So we provide regression, classification, binary classification, and multi-classification. In each of those machine learning tasks, we almost provide 20 different algorithms, and pretty much very optimized to do the best job. And if you don't like them, you can bring your own algorithm.
Okay. Great. We are run out of time. There are more questions which I am going to answer all of them offline. I just want to say thank you so much for joining us today in this webinar. As I said, there are more questions that's coming up. I'm answering all of them offline after this webinar. It was great to see you here. We are really interested to hear your feedbacks and your interesting topics for our upcoming webinars. My email address is goli@flexrule.com. If there is anything that we can cover in our next session, which you are more interested, please let us know. Thanks, Arash.
Thank you, everyone.
Great. Nice to see you all, guys.